Thanks for the warm introduction. So I'm Aaron Grant, one of the co-founders of a company called Thalmic Labs. And we're a technology company that is building hardware and software to give people new abilities. And that's really what technology and the digital world can do for us as humans. They can give us new abilities when we use them well. So I want to just talk a little bit about what's in store for the next 10 years. So there's a well-known and maybe now overused quote from the famous science fiction author Arthur C. Clarke, which says that any sufficiently advanced technology is indistinguishable from magic. And this magic can arise in many ways. At one point in time, just being able to talk to somebody who wasn't in the same physical location as you were would have seemed like magic. These days, we have algorithms that can automatically recognize your friends and tag their faces in photos, kind of like magic. And over the next decade, I strongly believe that a lot of this magic is going to come from new ways in which people and technology will interact. But the thing is, there's a couple different paths that we can take here. And the first is towards this kind of dystopian cyborg future where people end up with all this technology all over their bodies, built into their bodies, basically taking over their bodies, just kind of sitting at home all day, plugged into the matrix, if you will, kind of like this guy here. And I don't know about you, but I want to avoid this at all costs. The second path, and what really drives us and inspires us at Thalmic Labs, is the idea that when we take technology and develop it carefully and apply it thoughtfully, we can use it to really enhance our lives and as I was saying earlier, give us new abilities. If we pay very close attention to the way in which humans and the technology interact, how it fits in with our real lives and the habits and things we already do, I have no doubt that we'll be seeing new technologies very soon that will become just as natural as using a knife to cut a pepper or using a toothbrush in the morning to brush your teeth. And so when we started Thalmic, we looked at a number of the emerging technologies at the time. So this was about 3 years ago. Google Glass was a product that had kind of just been announced. We didn't know anything about its success or failure at that point. And you know, it's obvious now kind of where that's ended up for the time being. But despite their many challenges, smart glasses and products like this they're very interesting because of the potential they have to aid users in ways that laptops and smartphones will never be able to do. The thing is, just sticking a screen in front of your face isn't going to make a compelling product. And what the real question you come up against is, you know, how would a user interact with such a device in a way that actually makes sense? There's the touchpad thing on the side of your head, which is kind of okay, but in a lot of situations it's impractical or it's impossible to use. There's things like voice control, which has seen huge advancements over the past few years, but it's only great in specific situations. If you're driving in your car, awesome. If you're sitting on the subway and it's quiet and you don't want everyone to hear the conversation you're having with your girlfriend, probably not so great. And so these aren't nearly enough. The other thing is that some people might be tempted to say, mice and keyboards are pretty good. Why don't we just continue to try and use these forever? I mean, why else would someone invent these keyboard pants here? But I wouldn't be so quick to jump to that conclusion. Keyboards and mice work really well with today's technology because they were designed and evolved together. But even with something like smartphones, the typing situation on a smartphone is still far from ideal. I think everyone here, no matter how good you are at typing on your smartphone, is going to be faster and more accurate at typing on a real physical keyboard that you can put your hands on. Just to take this one step further, just to illustrate the importance of advancing the interfaces along with the technology and the computing power, imagine what would happen if you had your smartphone, it had all the same power that it has today, but it had a punch card interface. You wouldn't be able to do much of anything with it at all, and it would take a really long time, and it just wouldn't have made sense to have all that computing power in that. So in order to take advantage of all of these next generation technologies that will be able to do all these awesome things, we really need to build interfaces that will allow that. And so one of the things that we thought of at Thalmic Labs, and one of the areas that we thought was a little bit underexplored, was the idea of using your hands to interact with the digital world the same way that you do with the physical world. And so from that, the idea for the Myo gesture control armband was born. And it's a slim sweatband-like device that you wear on your forearm, just like I am right now. And instead of relying on an external camera to track your motion and recognize your gestures, it actually uses the muscle activity that it measures from your muscles to figure that out. So check out this video to see it in action. Video speaks, I don't know, more than 1,000 words. So basically what's going on here with the Myo armband is that there's these 8 sensors around the outside of the device, and they're detecting the electrical impulses in your arm using this technique called Electromyography, or EMG, which is a technology that had existed in a clinical setting for a long time, but had never been applied before to a consumer product. This graphic here just gives you kind of a high-level idea of what this looks like. So you have a number of these different signals, which just looking at them wouldn't really mean anything. We feed them through a bunch of different processing steps, do some machine learning on them, and end up with a representation of the hand gesture that you're doing. And then combining that with a motion sensor, like what you'd find in your smartphone, we can do all of the things that you saw in that video. So it's been an exciting first step with the Myo armband into this kind of what we think of as the next generation of human-computer interaction. But more important than the product itself are a couple of the key things that we learned along the way. And the first is that interfaces tend to enable and shape the applications and form factors that follow them. We've seen this many times throughout history where we saw mice and keyboards. This is the very first computer mouse prototype here that enabled graphical user interfaces, which then enabled the widespread adoption of personal computers. We've seen touchscreen technology enabling the smartphones that I'm sure probably every single one of you has in your pocket today. And now we're seeing new interfaces like voice and gesture that are starting to allow us to access the digital world through an ever-increasing number of ways, everything from your car to the clothing that you're wearing. And the second thing we learned is that the factors that have traditionally limited us in advancing technology have changed. And for many applications, we're now not nearly as limited by the computing power, the storage density, the network connectivity as we were just a few short years ago. Those things are still important, but they're no longer the limiting factor that's going to gate how quickly we can move forward. I really believe that we've reached a point now where the biggest innovations are going to come in the form of new ways in which humans and computers will interact. And of course, this has always been important, but because of these other technological limitations, we haven't been able to fully explore all the different ways that humans and computers could interact. And so, now that a bunch of those barriers have been removed, now that we have a good amount of computing power and connectivity and everything, there's so many new ways that we can explore over the coming years. To give an example of this, this is not a new situation. We've had situations like this many times in the past, and one great example is kind of this weird trend, or what might seem like a weird trend at first, with the evolution of phones and cell phone technology. So, we started out obviously with these gigantic bricks that you would carry around that kind of somewhat passed as a cell phone, and then it was clear that this had to be miniaturized and made smaller to actually be that practical. And by the mid-2000s, we had done exactly that. We had devices like the Motorola Razr, this super thin phone that's super small, easily fits in your pocket, really convenient to carry around. But something weird happened at that point, which is that phones started to get bigger again. And the reason for that is that having a big screen was the only way to effectively allow humans to interact with the new and powerful software that could now run on these devices, or to watch cat videos in HD, if that's what you like to do. But the key here is that if we hadn't been limited by the interface at this point, we might be in a very different situation. Phones might have continued to shrink, and we might have ended up with phones like this. Now, imagine trying to actually use this phone. It sounds like a pretty silly question, but in reality, it's actually very similar to figuring out the problem of how we interact with all the wearables and kind of new embedded technology that we're seeing today, if not even harder. And this brings me back to a second important point that I want to make, which is that if we want to continue building technology to improve our lives, we need to design flexible, adaptable new interfaces that can reduce the need for what I'm going to call explicit interaction. And until that happens, new form factors like wearables are not going to come anywhere near replacing that slab of glass that you carry around in your pocket. When I talk about explicit, this is what I really mean. So I Googled the definition of explicit here, and I think it's pretty perfect. So we get stated clearly and in detail, leaving no room for confusion or doubt. And this applies, I think, really well to the majority of your interactions with technology today. And it doesn't even matter whether you're using a mouse or a keyboard or even talking to Siri. The thing is, you still need to tell the computer exactly what you want to do. And if you get the instructions slightly wrong, or you say something that the computer doesn't quite expect you to say, you probably won't get the result that you're looking for. And for certain tasks, this explicitness is awesome, and it's what gives computers a huge advantage over people in lots of cases. Like, you want to go and enter a bunch of data into a spreadsheet to calculate some statistics. That's a lot easier to do when you can just type it up on a keyboard, and it's there, and you can hit a button, and you get all your results. But in many cases, if we could interact with computers more like we interact with people, where some of the context is understood, and you don't have to spell everything out letter by letter, our interactions and with technology would be a lot smoother and easier. So in order for technology to go in this direction, to give us as humans new abilities, the really important thing is that we continue to make technology more flexible, adaptable, and less explicit. Products like Google Now and other similar products have, I think, started out in that direction, but they're really just scratching the surface of what's actually possible. The really interesting thing about something like wearables is that because they're on your body, they're everywhere, they're places where computing has never been before, they have the opportunity to collect and make use of all this data in the digital world that you never would have gotten access to before, whether it's what you're eating, your lifestyle, who you're interacting with, how you're interacting with them. The list goes on forever. And it's these types of data that will start to allow us to reduce the required explicitness in the way that we interact with technology. So one of the best parts about working with fundamental and enabling technologies like human-computer interfaces is that you can never really predict for certain what new applications are going to be enabled by it. When we designed the Myo armband, for example, I never imagined that world-famous DJ Armin van Buuren would now be using it on his world tour to control his lights and I think even fireworks now during live performances. It's pretty cool to see things like this happen that I never would have dreamed would be possible. Or to be able to fly a drone just with the wave of your hand. And if I don't get arrested before I can do this, I'll give you guys a quick demo here. There we go. So while flying drones by waving your arms around may not be the most useful everyday ability, it illustrates the notion that we've barely even begun to explore these new ways in which humans can and will interact with technology. And I think we're really at a point now where this is primed to happen in the next 10 years. We're ready. We have the enabling technologies at our disposal to make these huge, even exponential advances very, very soon. It's this kind of thinking that anything is possible, that we're really just at the beginning of a revolution in human-computer interaction where we're going to see these new flexible, adaptable interfaces that don't require us to interact so explicitly with our technology, that are super interesting to us at Thalmic Labs. And it's this situation where the technology kind of starts to fade away, and the abilities that we gain from the digital world actually start to become indistinguishable from innate human abilities, such as sight or touch, just like magic. Thank you.